Chapter 6, Day 5. We're going to go over Pythagorean triples. We'll get that in a second. It just starts with some review, like, hey, do we remember how to go ahead and complete these right triangles? So hopefully we know that we have some ways to do this. So here's the 30, 60, 90 triangle. I will go back over. Shoot, I didn't look. So I know that my hypotenuse is 12, right? So I'm going to go to my graphic organizer to 30, 60, 90s, and I have the hypotenuse of the 90-degree angle. So the first thing I'm going to do is divide it by 2 to get my 30-degree angle. So I'll go over here. I will divide it by 2. 12 divided by 2 is 6. And then from there, the next thing I'm going to do is 30 to 60. I'm going to multiply by the square root of 3. Right? So I will take this. By the way, I think you'll notice that my actual graphic organizer looks a lot better than the one I made for this video. Anyway, so this will be 6 times the square root of 3. So hopefully you're okay with that. This one, it looks like we have a 45-45 triangle. So I know that if I am given a leg, so we have the 30-degree leg and I need to get the hypotenuse. I will go ahead and multiply by, oh wait, I'm sorry, I need to be looking at this one. I have the legs, I need the hypotenuse. So the leg will be the same, but I just need to multiply by the square root of 2 to get the hypotenuse. So I will go here, the leg is the same, I will multiply by the square root of 2 to get the hypotenuse. I'm going to pause for a second. Mention too, because obviously what we have here is an issue. It's not one of these special right triangles, so we can use the Pythagorean theorem. And hopefully we already know that this is a 5, right? It's a very famous triangle. The 3, 4, 5 is the most common right triangle that there is. But anyway, if we don't recognize that, we'll get 9 plus 16 equals x squared. 25 equals x squared. We'll square root both sides, and we will get that 5 equals x, which is what we expected to get there. But if we look over here, you know, 3 doubled is 6, and 4 doubled is 8, and 5 doubled is 10. Would that work? I mean, is it that simple to get that to work? If it is, 36 plus 64 should equal 100, and it is. So what we've noticed here is that we have this one, and hey, look, 3, 4, what if this is 5,000? And we're beginning to see what a Pythagorean triple really is. It's when we have the same ratios and we can sort of use those ratios. 3 to 4 to 5 is the same as 6 to 8 to 10 is the same as 3,000 to 4,000 to 5,000. Those ratios are the same. Now obviously this one, not the same. We're back to 30, 60, 90s, and they give me the 30-degree side. So if I go here, a 30, 60, 90, and I have the 30-degree leg, I'm going to double it to get the hypotenuse. So we'll go here, I will double this to get the hypotenuse, and then I will multiply by the square root of 3 to get the 60-degree side. So I will multiply it by the square root of 3 to get the 60-degree side. So not too bad there. This one, another one where I'm going to have to do some math, so we'll just call this C. So 5 squared plus 12 squared equals c squared. 25 plus 144 is c squared. 169 equals c squared, and the square root of 169 is 13. So I know that this must equal 13 to complete that one. And now, hey, let's look. 5 times 3 is 15. 12 times 3 is 36. And 13 times 3 is 39. So again, will that work? If I grab a calculator, will 36 squared plus 15 squared equal whatever 39 squared is? And you can see that they do equal, so that must be 39. So kind of a nice little shortcut there. And then the last thing we're going to do is we're going to complete this one, which I guess I'll do over here. I'll call this b. So 9 squared plus b squared is going to equal 41 squared. I know that this is going to equal 81 plus b squared equals, I have no idea what 41 times 41 is. So 41 squared equals 1681. I will subtract 81 from each side. So b squared is going to equal 1600. I will take the square root of each, and b should equal 40. 40 times 40 is 1600. So again, I'm assuming, I already know that 41 squared is 1681, so 9 squared plus 40 squared had better equal 1681, otherwise I get a problem, but it does, so I know that this is b equals 40. But again, if I change these colors here, this ratio, and this ratio were the same, as well as this ratio and this ratio. And these are known as Pythagorean triples, where the ratios are the same, and then we can just use that logic to sort of keep going with it. So these are the two most famous Pythagorean triples. And if we just sort of go here, again, it says, with your team, determine the missing length for each triangle. I don't know if I want to do 614. Let me pause and take a look and see which problems I want to do. It's more of the same, where some of these are going to be Pythagorean triples and some of them are just going to be special right triangles. So just some extra practice. It would be a really good idea for you to be pausing this video and just checking your answers as opposed to sort of going through it the way I'm going to do it. At this point, I will say, I hope you guys understand how to use this graphic organizer. I don't want to keep jumping back and forth every problem. I think I've done enough of that, hopefully, that you kind of get the feel for how to do that. So I'm just going to sort of go through this. I know that I'm going to have half of 13, so half of 13 is 6.5, and I know that this would be 6.5 times the square root of 3. Another way to write it, honestly, which I think might even be a better way to write it, but I know a lot of kids don't like fractions, is I could say 13 divided by 2 is my 30, and then 13 times the square root of 3 over 2 is my 60. So either way would be fine. On this one, my hypotenuse is 12, so half of that would be 6, and this would be 6 times the square root of 3. Over here, I know these are going to be the same, so I'm going to get 25 times the square root of 2. On this one, I'm going to double 7 and get 14, and then 7 square root of 3 for the 60-degree side. Over here, I don't really know, so I suspect this one might be a Pythagorean triple, so let's see here. So if I multiply 13 by 4, I get 52, and if I multiply 5 by 4, I get 20, so if I multiply 12 by 4, I'm going to get 48. So that's my 5, 12, 13 Pythagorean triple right there. And then this one, obviously, if I have to multiply by the square root of 2, well, I better divide by the square root of 2, right? And I can't have an irrational denominator, so hopefully you're seeing how this whole chapter comes together. So I'm going to get 3 square root of 2. And again, I think the easiest way to check, did I do this correctly, is multiply this by square root of 2. 3 times 2 does equal 6, so those must be that. Let me go ahead and set up the end of the chapter. We've done 614, so we'll go down to 615. It says Diana looks at the problems below and thinks she cannot do them because they're all variables, right? So Eric points out that they're related to the previous triangles, but instead of numbers, they're using each side length is given in terms of a variable. So yeah, that makes sense. If this is x, and then this would be x times the square root of 2. And if this is y, well, this must be 2y, and this must be y times the square root of 3. And if this is 3x and 4x, this must be 5x. And if this is 5x and 12x, this must be 13x. And again, if this is x, this must be half of x. Another way to write half of x would be x over 2. And then if I multiply x over 2 times the square root of 3, I'm going to get x times the square root of 3 over 2. So kind of interesting, but the logic holds, everything's still the same. Now it says use your right triangle patterns to calculate the area and perimeter of each polygon. I do think that these perimeter area weird shape things show up a lot in SAT prep, so I think it's worth seeing at least some of it. So take a look at this one then. So if I look at this one, I'm really breaking this into 2 shapes. And for the area, we'll talk about, well, I guess let's do the perimeter first. So these all have to be 6, right? Because they have 1 mark each. So 6 plus 6 plus 6 plus 6 plus 6 I have a perimeter of 30 inches. Now let's go ahead and look at the area. So I know that this is just a square, so 6 times 6 is 36 inches squared. And now I have to deal with this triangular shape up here. So this is 6, this is 6, and I know that this length right here is 6 as well. Right, so these are all 60-degree angles. I have myself an equilateral triangle up here. So if you think about it, I need to get the area of this triangle being the base times height. So I know that this is 6. I need this height right here. Well, if this is 60 and this is 90, this would be 30. I know that this distance is 3, so half of 3, right? The 60 is going to be 3 times the square root of 3. I hope you guys are okay with that height. I know that looks really small. Let me redo this one. I think it'll look better if I hope we're all okay with this being an equilateral triangle. That's 60 degrees up there. I know that this length is 6 and this length is 6 and this length is 6, right? This length would be the same as this. So that must mean that all the angles are the same. And then if I cut this thing in half, I obviously have a 30-60 triangle, right? Well, the 30-degree side, the hypotenuse is 6, the 30-degree side, this is now the 30-degree side because the 60 got cut in half would be 3, and then 3 times the square root of 3 would be the height. Right? So think about it. The area of a triangle is half of the base. Well, we know half of the base is 3 times the height. So it'll be 9 times the square root of 3. So this area of the square is 36. The area of the base is 9, I'm sorry, of like the top of this triangle is 9 times the square root of 3. So, I mean, I know a lot of us don't like to look at that. So technically, we're okay to just say that the area, by the way, is 36 inches squared plus 9 times the square root of 3 inches squared. That's a completely acceptable, actually it's probably the better answer, but I know a lot of us don't like it. So I will instead add those together. So 36 plus 9 times the square root of 3 is going to equal 51.59. So there you go. We get 51.59 inches squared. That's what my area is going to be. And then we just do the same kinds of things for this one, right? Like we know here that we get this square, and then we have this 45 triangle. So if the hypotenuse is 6 times the square root of 2, I know that the legs I'm going to divide by the square root of 2 are going to be 6. So I'm going to get something that looks like this. So my perimeter is going to be 6, 12, 18, 24 plus 6 times the square root of 2 inches. And again, if you don't like it written like that, I will just say 24 plus 6 times the square root of 2 is going to equal 32.49 inches. Or our area, again, we know that this is all going to be 6, so 6 times 6 is 36 inches squared. That's what this is going to be. And this is just going to be half of the base. Actually, this whole triangle, right? So we could just say base, which is 6, times height is 6, 36, and half of that is 18. So we'll get 54 inches squared. And again, this is just half of a 6 by 6 square, right? So if the whole 6 by 6 is 36, well, half of it's 18, and 36 plus 18 is 54. Just sort of turn this thing into a rectangle. We know that this is 3. Well, this must be 4, right? 3, 4, 5 triangle. This is 8. So we can do our perimeter. Pretty simple. 5, 13, 16, 24 plus 4 is 28. Actually, I guess these are feet. 28 feet. And then our area is 8 times 3 is 24 feet squared. And then this is going to be half of 3 times 12. Well, that's 3 times 4 is 12, which is 6 feet squared. So we'll get 30 feet squared on that one. And then finally, just to end this up, this is kind of a neat little trick to use. It says, Emma's helping her dad build a backyard shed. They have put up one wall of the shed, and they want to check whether the wall is perpendicular to the floor. The shed kit instructions say to use the 3-4-5 rule. Essentially what they're saying there is this, that you'll know something is square if the side lengths are 3-4-5, right? If it's got to be a right triangle to have that 3-4-5 ratio. You can't make a 3-4-5 ratio if it's not a right triangle. So if you want to check to see if this guy's wall looks right, it says, so 3 feet up the edge of the wall, puts a mark, and then 4 feet along the floor, and he puts a mark. This should equal 5 feet or 60 inches, right? If it's square. But it only measures 55 inches. So that tells you he's not square, because you can't make this triangle be this, otherwise it would have to be square if it was 60 inches. So 55 means that's not a right triangle. What a convoluted video. Don't forget the whole point of this video, which I think is lost in this lesson. Like, I don't know. I'm not sure I really love the lesson that I went through the whole way. I think I still have it back here. The whole point of this lesson is these Pythagorean triples, that sometimes these ratios remain the same. So that's the big takeaway in this lesson. Kind of got lost.